So suppose you want to have, let's see here, suppose you're taking, you've got 0, you've got 1, you've got -1. And I want to send, let's say, -1 to I and 0, 0 to, I'm going to send -1 to infinity. I'm going to send 0 to 3, and I'm going to send 1 to 0. Right? Can we find a fractional linear transformation that does that? Can we write it down? So I'll do the easy part. To send 1 to 0, I simply slap a z -1 in my numerator. Voila. That will send 1 to 0. I want to send -1 to infinity. To achieve this, I simply put z plus 1 in the denominator. Now, that will send -1 to infinity. Now, these two things can be achieved while simultaneously rescaling this by a. So to find a, I plug in 0. So I've got, that's 3, and that's a times -1 over 1, apparently. So therefore, f of z equals to -3 times z -1 over z plus 1. This is a Mobius transformation which maps the points -1, 0, and 1 to the points infinity, 3, and 0. Right? Or let's make it more interesting. Let's map it to 3i. There we go. How would that change things? So put an I here, which means a is equal to, that just literally just slaps an I there. Okay. That makes it a little bit more interesting, though, because if I was going to graph over here where it maps to, 0 maps to 3i, right? And what else happens here? -1 goes to infinity, great. And 1 goes to 0. Let's see here. So I guess if I just was to write down, it might be interesting to write down then phi of z equals to perhaps the argument. We could do that, see what happens. The argument of f of z. Right? Rats. Well, the more interesting ones are if I can see, the thing is I can choose a Mobius transformation to map this line to like a circle, and then that's more interesting. But I'm having trouble doing things today. I'm sorry, guys. But anyway, the larger point here is this would be, to figure this out, I'd actually have to figure out what the imaginary and real parts of that are, and then I'd take the inverse tangent of the quotient of those down here, and that would give me a kind of funky solution over in the half plane that's somehow based on this. But I'm sorry, I haven't gotten the idea across to you guys today, so I'm sorry. You know, this happens sometimes with this material. I have trouble with this particular topic, and this is not wrong. I mean, this is not helpful, but this is not wrong, and like that's kind of like the main example I want you guys to be able to do is something like this. But I want us to look at the example. So let me just get to the point here. There is a way to, you know, take for example like the unit disk and map so that you take like half of it, and it maps to like this 1/2, like over here. Maybe this half maps to there, and you know this part maps to over here, like that, right? And so if I make a solution that has like 10 here and 20 here, I can also get a solution over here that has Laplace's equation with 10 here and 20 there. And the way to do it is there's a Mobius transformation that will map this line to this circle. All right, so I'd like to show that to you, and obviously I haven't done it today, so I'm going to just shift the class back a day because everything's messed up. So just to simplify life, what I'll do is I'll make quiz 1 due not Thursday but next Tuesday, and we'll shift everything a day, if that's okay. Was the test supposed to be Wednesday? It's supposed to be Tuesday? Yeah, so the test moves to Thursday. And hopefully I'll actually lecture this material Thursday in a way which is like reprehensible for humans. So I'm not even going to bother to post this, honestly. Like this is just so horrible. It's not even postable.
No, you should still post it.
Still post it?
Or no, just post it to us. Like post it in Canvas or something.
I should.
I'd be really nervous because at least we'll know.
No, it's okay. I have done worse things.